Okay, Moneysocket. So this is a proof of concept. I'm going to demo it and explain what's going on here. So this is on GitHub. The link is in the description of the video. So yeah, and this is meant to be just a sort of a discussion. Nothing here is final. Nothing here is I have a strong opinion on. I just had to get the idea out there so it can be commented on by others, with a sort of a clear idea of what I'm talking about first. So yeah, this is example code. Very briefly, so the motivating problem is SparkShot here. So this is what I work on. With the user interface, like this is meant to be a sort of an interactive micropayment site. So people reveal pixels. So right now, we have to copy this bolt 11, or somebody has to scan the wallet. Now that's not fast. So, and particularly when we're dealing with like very, very small amounts of Satoshis, the user interface of all the screens of like, are you sure you want to pay, or even, just scanning the, with your phone, the QR code, all of that's too slow. We want people to be able to like cycle through the app to do a micropayment, then to do another micropayment. So that's what our app is built around, and we've kind of reached the limit of what we can do in our user interface. It's really a question of building better wallets. So that's where I'm coming from. I'm going to come back to SparkShot later because I want to actually show the code specifically here in this repo. So the idea is, so this is the client that's packed in the GitHub. I'll just pull that back here for a second. So yeah, under this browser folder, that's what I'm running here in the browser. So it's running in the web. Now in this window, this is a C Lightning instance, and this is, well, I'll explain this first. So this is a C Lightning plugin. So it's running, this is the instance running here, but also the plugin. So when I go and connect, so I'm connected to this C Lightning node. Likewise, this is the LND equivalent. So this is also in the repo here. So the C Lightning plugin, and then this is the LND equivalent. So these are all just sort of the wrappers to interface with the daemon, and then the logic of the actual WebSockets and all that is in that folder. So yeah, LND, C Lightning, but then here it's the web browser that's connected to it. So over the WebSocket, what's happening is I'm getting the balance sent to me. So this is granting the WebSocket permission to request an invoice and also pay an invoice. So if I do that here, if I want to push a sat over there, so I just requested that. So we incremented here and we decremented there. Now it's a little more than one sat because there's fees involved. So these two nodes are connected up to the SparkShot node. So there's 3 Lightning nodes. So they're just paying each other through that node. So when I'm pushing and pulling here, this is about as fast as it can. Yeah, I got Spark running at the same time. So yeah, the balance gets updated minus the fee based on this settled. So this is the interface. There's no QR codes here. There's sort of the QR code gets pre-authenticated, or sorry, the WebSocket gets pre-authenticated to be able to spend. So there's sort of there needs to be some sort of permission model. I just have sort of a balance limit here set, but some sort of authorization to authorize an app such as SparkShot or some other app to essentially pull sats from the wallet. So the app would connect to the wallet and say, please pay this invoice. And if it's within the set parameters, it'll just go ahead and pay it with minimal fuss. There's no like, you have to click OK. It's sort of a preset spending pool. So that's pretty fun to send stuff back and forth. Now, this stuff is also, WebSockets allow multiple connections. So if you do have a wallet, there's the potential here to have multiple consumers of that wallet to be able to send stuff. So for example, if you had 3 different wallets, you could kind of daisy chain these where from wallet A you can pay wallet B, and then this would be connected to wallet B. So then from wallet B you could then go pay wallet C. So this is sort of becomes a way to coordinate moving money around very fast between wallets. So that has other implications outside of gaming use cases, perhaps like trading or something like that. To be able to move money in and out of exchanges and into the wallet quickly. That this would be potentially a way to do it with low latency WebSockets. Okay, so that's in a nutshell this working with itself. Now I'm going to take this back to SparkShot for a second. So I've actually this is a modified version of SparkShot that's able to connect to this. So if I refresh the window, there's a connection open. Yeah, because I'm running off localhost, doesn't have all the images, so don't worry about that. But yeah, so I can connect into it. The thing that we desire here is, so if you're, oops, I kind of screwed that up. So if you're using an interactive web app, let's actually make them happy. So you're selecting your pixels, and then you type your message, and then we want to pay. So this is when all the user interface friction happens in our app. Ideally, we don't want to be even showing a QR code unless if that's sort of the default failback, where we're just demoing it. So maybe you have your wallet in your phone and you want to go scan. But ideally, we don't want to show the QR code at all. We just want it to happen. So I've got this connected to the WebSocket, and if I press enter here, it just goes ahead and pays, and then we get the pixels revealed. So if you're familiar with SparkShot, we do echo those into Telegram. So that just rendered the purchase. So I can do that one more time, and I can show. So in the background here, QR code, go pay, and so then that gets echoed into this Telegram space. So really, ideally is like you'd be typing in this app as if it were an instant messenger app, and the pressing of the enter is the thing that orchestrates the payment. So yeah, that's ultimately what I see this is a way to have wallets that are instantly ready to pay under some permission model, and then if you grant the app permission, it can start spending those sats as quickly as possible. Okay, so briefly, so there's other potential use cases. So credit where credit's due. Christian Moss had this rigged up back in June of last year. So it's the idea of like a fighting game where there's this interactive, and it's being able to pull and push sats from there. So this is kind of a general pattern where a game of this type, whether it's sort of a real-time combat game or real-time strategy or even turn-based strategy. I mean, SparkShot kind of boils down to that, in my opinion. This is sort of like a turn-based type game. I would say that, so I drew kind of a picture of it. So if you had like a game and then players connected, and then each player brings their wallet, so the game logic is connected over WebSocket. This is roughly how the game here works. So it can pull and push sats in and out of the wallet. And then potentially that could be chained, like if you had a custodial wallet. So the thing that they authenticate, when they're sitting in front of the game, they authenticate with a custodial wallet. The WebSocket would just go to the wallet backend, and then another player could come up with a non-custodial wallet, and they'd have their WebSocket. So to kind of define how that would work in a game is really sort of the base example of what I showed here. Okay, so this could have applications, perhaps in like gambling applications. You sit down at your roulette table, you authenticate your wallet once, so then your wallet is just showing you sort of a simplified balance, like these phones here are doing. So as you're gambling multiple rounds or whatever, you just got your phone in front of you, and then based on how the game is happening, it's either pulling or pushing your sats in there, and then perhaps that would have to depend on some sort of authentication. So if you got disconnected, you wouldn't lose your bet, depending on how you design it. So in the protocol, we'd perhaps need to figure some of that out. And then I touched on briefly the notion of a trading use case, where if you had two exchanges, a couple exchanges already have Lightning implementation. I believe they even have like LNURL connected. But maybe that's too slow. So if there's a short-term arbitrage opportunity, maybe you have your trader bot that's connected to the wallet and then to exchanges, and it's able to move money in and out, kind of like what I suggested here, from here to there. Oh yeah, so one thing you noticed is the balance went down when I paid on SparkShot. That's because these are all connected here. So when the thing actually got paid, it sent out what the new balance was. So that's kind of cool. So yeah, basically focusing on the low latency use cases is really where I think there's a niche, and I think you have to get in the mindset of WebSockets for that. So that's where I'm kind of working from here. So yeah, I'm well aware of the LN URL stuff. So there's some good ideas, I think, in authentication and kind of how to present these QR codes for being able to set up a relationship. So maybe that's relevant. Maybe ultimately LN URL needs like a WebSocket extension, and maybe that's what we end up doing here. So yeah, that's certainly within scope to understand that. And different ways, like also like LSAT has their sort of macaroon authentication. So maybe that this is something that has to potentially accommodate that. So yeah, this is an invitation to correct me or inject ideas or propose something different. But yeah, really what I'm after, what I care about the most is kind of fixing this UI to kind of skip wallets when that's appropriate for micropayments. Okay, that's enough. That's 11 and a half minutes. So thank you. Hope to see you in the Telegram, and take care.